I can ask you. Back there and so okay. So how do you never see? I don't like this arrangement. It makes it so. What do you say? Cry about it? Promise. I'm gonna like penetrate him right now.
You can't solve this if it doesn't say equals 0.
Yeah. Oh, no. So do we can't solve it.
So put it equals 0 in. Because you just assume it was equal to 0, that's fine. Okay, so I'm grouping these. I'm splitting it up into 2 and 2. Because it's four terms, so. The 12 and the 15, they both divide by 3. And they both have an A. 12 divided by 3 is 4, and there'll be an A left. And 15 divided by 3 is 5. They both divide by 4. And in fact, that 16 is negative, so we're going to take out a negative 4. So negative 16 divided by negative 4 will be a positive 4 with an A. And 20 divided by negative 4 will be a negative 5. Parentheses match. We'll do 3A minus 4 and 4A minus 5 equals 0. You gotta have the equal 0.
I got that right.
This isn't done. I'm not boxing it. We're not done. This is factored. This is a very good job. We took a problem and we wrote it as a product. Something times something else. So zero product property says if we need to solve it, if the directions say factor and solve, that we're going to do the little mini equations. So I do 3A minus 4 equals 0. And 4A minus 5 equals 0. That's the last step of solving. Do your opposite operations to find out what A could be.
Oh, we're gonna do the 0 thing.
Yep. A is 4 over 3. And A is 5 over 4. Two fractions. So that's a full summary of what we did last week, really. Taking out greatest common factors, setting them equal to 0, grouping, that's it. So let's look at your homework, page 110. What's that? Friday's homework. No, we have a whole thing. I'm doing something new today.
Thomas. We should. I'm not freaking out. I'm gonna just type some weird stuff in there.
Patrick, put your phone away. Let it go. Take a break. Live in the moment. Not
Live in what moment? Math moment?
This moment with the people you're with. Not that whatever people are connected to your phone. No, these are the people in your room with you.
I'm with Patrick
You don't need to
24/7.
be in an abstract space right now. This is real.
That is a lot. Let it go.
Stop being an abstract space.
Yeah, baby, I don't need your commentary.
Abstract space is
Miss, I live in abstract
Let it
space
go.
all the time.
Let it go. Wait, homework.
I didn't even know we had
Someone's
it.
your
Was it
girl.
25 to 30?
What page is that homework?
Oh no, I did not do this homework.
I don't think anyone did. I'm not gonna lie.
I'm not doing that. Pretty sure it's 110. It is. But
Yeah, what numbers?
13,
That had countless birthday parties this weekend. Oh. I'm not gonna lie. I had 30 birthday parties. I did all of them, bro.
I'm done. Didn't do it.
I gotta figure out some posts.
Yeah, I didn't do it.
That's fine. I think I got me and my buddy Jake to take all this. Yes. No, my best friend Ava's gonna be coming.
Oh, I know your best friend.
Yeah.
Where does she live? You're going with her? When? Oh, so she's going with you?
I'll go to the party.
Yeah. So I don't ask you to rate it like that because I find students think those are ordered pairs and they're not. Because those aren't parentheses, those are brackets. So that's like the set of solution. They are ordered pairs by themselves. There's an ordered pair at 32, 0 and another ordered pair at 0, 0. But they don't go together.
They don't at all. No. What if like I did my homework in my head? What if like Miss Miss Baldwin? Hey, you guys. Um, a lot. Trust me, I'm dodgy. I haven't even cut up on my work. Miss Baldwin, what if I just like did my work in my head? What if I telepathically did my work in my head, transferred it here? Okay. All right. Well, I actually need to catch up on homework. I have like a whole bunch tonight. What? Your birthday? When is your birthday? Oh, it's Friday.
Priority went by you. Go ahead and
All right. Have a fun, bit, guys.
wait.
Thomas.
And yeah, no, when is it?
So I would do x times x because they're the first two terms. X times -4. So you fully distribute the x. And then you distribute the -5. -5 times x and -5 times -4. Your first, so you cover up the -5 and you multiply the x in, and then you cover up the x and you multiply the -5 in. So the product of x times x is x squared. -4x minus 5x plus, I wrote that wrong. That's a 5 there. Plus 20. Man, this is almost exactly like your quiz question.
What are we gonna be able to see like when
The grades are in.
Oh, they are.
But you won't be able to see them till tomorrow. And please don't go there right now. So x squared minus 9x plus 20. So our goal today is for you to understand how to start in standard form and work backwards to the parentheses, which you've been working on with 4-term problems, but not with 3-term problems. Okay? So our goal today is to really work backwards. Okay, next one. X times x. 2 times x. Negative 8 times x. Negative 8 times 2. X squared plus 2x minus 8x minus 16. X squared minus 6x minus 16. Everybody okay on that one? X times x. X times negative 5. Negative 2 times x. Negative 2 times negative 5. X squared minus 5x minus 2x plus 10. X squared minus 7x plus 10. All right, I have to erase this. Is everybody good on this one? So when you're done, you're going to go and you're going to open up Google Chrome. You're going to go to desmos.com. So standard form, what we're actually going to put into Desmos is x squared minus 7x plus 10. And we're going to take a look at what the graph looks like. So I wanted to show you and give you a chance to kind of explore Desmos. Some of you guys have been on it quite a bit, and some of you have never seen it. So in graphing this, that means it would be equal to y because we graph on the x and y axis. Go to the graphing calculator in Desmos. So hopefully it looks something like this when you get there. And so now we're going to type in x squared minus 7x plus 10. And then you're going to answer the questions 1, 2, and 3.
Square.
You guys have a little keyboard that should pop up.
Nope.
Find the keyboard.
Oh,
Yep, find the keyboard. Oh, without the keyboard, you can do Shift 6. Because that's that symbol on calculator. We're not doing a code. Just go to the graphing calculator.
I think it's non-linear. I think the graph is non-linear. Keyboard function. Minnesota fire in school. I didn't even know this. You don't know?
Nope. We don't need to do that. Answer your questions, Thomas. 1, 2, 3. Answer the questions. 1, 2, and 3. Is the graph linear or nonlinear? What is the y-intercept and what is the x-intercept?
Dude, I'm not excited to see what we're doing in this today. Oh, it's the essay thing.
Alright, so this is a nonlinear graph because it's curved. Number 2, what is the y-intercept?
10, 10, 0. 0, 10, 10, 0, same thing. No. You tell me I don't need to stupid that. No way. Yeah.
Oh, before you were yeah. No. Why was it back?
No way. Yo.
Wait, hey? Yeah. Like really?
Alright, so the y-intercept is 10. Number 3, what are the x-intercepts? Our x-intercept is at 2, 0 and 5, 0. So a lot of really important information here. Can anybody see the x-intercept in the equation? Is the x-intercept present in the equation? Where is it in the equation? This is your x. I'm sorry. Was I saying x-intercept or y-intercept? Your y-intercept is here. All right, you can go ahead and label it. So that 10 there and that 10 on the graph, that's not a coincidence. That's supposed to happen. Can you see the x-intercepts in the equation?
Yes. X squared.
Only in factored form do you see the intercept. So in factored form, it was x minus 2 and x minus 5, right? Is this how the problem started? Letter C, is this what it looked like? X minus 2 and x minus 5? Now look, our intercepts are 2 and 5. That is not a coincidence. That's supposed to happen. They're mathematically related. Okay? So if you have factored form, you know where the intercepts are. They're opposite, aren't they? Why is it positive 2 and positive 5, but our parentheses are minus 2 and minus 5? Joseph. Yeah. Yeah. So these are positive while these are negatives because you have to, if you move forward into solving these like we've been practicing and do x minus 2 equals 0 and x minus 5 equals 0, you get that x equals 2 and x equals 5. So the solutions to the quadratic show up in the picture of the graph. So you can actually use the graph as a check. You can solve your quadratic and see, okay, are those the numbers, are these the numbers that I found when I solved? So these are solutions. So number 4, go ahead and answer. Are the binomials that were multiplied together in letter C in the graph of letter C related in any way? All right, this is a good answer. Yes, if you solve the binomials, the answers are x-intercepts. Did anybody word that differently? If you solve the binomials, the answers are x-intercepts. Why would a mathematician call these points zeros? These are actually called the zeros of the graph. Why are they called zeros? Well, look at the ordered pairs. Look at the intercepts. What's always true about intercepts? They have zeros in them. Okay. So mathematicians decided to go ahead and call these solutions zeros because when you find them, your y value is 0. They're called zeros because the y value equals 0 at x-intercepts.
Yeah, it hurts so bad.
Alright, so now we have 2 kind of longer word problems. I think we did. What was our word problem Friday? Something falling off a cliff? A rocket launch? Launching a rocket. What was the other one?
I thought it was like a
That was the rocket. And there was another one. You just having your
It was
notebook.
an airplane.
No, it was the box.
Oh, it was a box.
Smaller box.
Yeah, the flower box. Good one. Okay. This time we're talking about a football. The football is kicked into the air. The height of the football looks like this, very much like the rocket equation we did Friday, where h is the height reached by the ball after x seconds. I want you to enter this into Desmos and tell me what are the values of x when h is 0. You don't type in h equals. You just put the negative 16x squared. You guys, if your thing's not showing, how do you get it to show? Yeah, but
Uh-oh.
if you hit like the window minimizer, your calculator should show up. Yeah, there's supposed to be a keyboard. It's supposed to be a keyboard. You need to zoom in. So you guys gotta practice zooming in Desmos. It's most difficult in the Chromebook. On a touch screen, it's the easiest. With the mouse, it's easier. But you guys, you gotta be pretty good on these Chromebooks. You're gonna be using them all for a year, so.
Just do this. To the left is zoom in, to the right is zoom out.
Okay, good job. It's plus 16x. Okay, so I can enter in like 10 equations here. I'll graph all of them at the same time, but if I don't want the red one anymore, I can just unhighlight it. So I just unclicked it, and now I just see blue. So this is what the football looks like. Height over time. Height over time.
Oh, that's a high.
No, it looks like only 4 feet.
I know that.
No, 2 yards.
They threw it straight up. Looks like 2 yards.
Exactly. Not even. Probably like
It's
an
actually
interception.
feet. It's 2 feet.
That's an easy interception.
The football is kicked into the air. The height of the football can be modeled by the equation.
It's kicked to the air. That's a bad kick then.
Just a little baby kick.
He ain't going pro.
It's only 1 foot. It's a baby kicker. Go ahead and answer it, guys.
Not even.
The value of x when h is 0 is 0 and 1. It's 0 and 1. Did you guys answer it? Then go on and do number 2, a little more difficult. This is an arch of a bridge. Without the calculator, I could have found 0 and 1 just by factoring out a GCF of negative 16x, getting x minus 1, and solving both of those. I would get x equals 1 and x equals 0. So I can do it with math, or I can do it looking at a picture of the graph. So now this is the equation you're going to put in, and you're going to tell me, can a boat that is 10 foot wide fit through the bridge?
You just hop over the bridge.
Practical, yeah, probably. You're going to hop a boat over a bridge?
Yeah.
Heck yeah, I would.
Take a ramp. You have an airboat? What is an airboat? Oh, that. Where you have an airboat? They're big. The big fan. Then you go to the swamp, try to find alligators. No, my finger hurts. I want it to hurt more. I love
10
pain.
foot wide though.
10-foot wide boat. Can a 10-foot you can untie like that. Can a 10-foot wide boat fit in? So it's
Boat.
0.5x. Were you able to enter it, Tony?
Yes.
Stop breathing. It's negative 0.5x squared plus what? Whatever here.
That is not a very tiny curve.
No.
I'm sorry.
You just tell him to know. I didn't say that. You didn't tell him to All right, you guys. So picture a bridge. I guess the 10-foot. It's like a pontoon boat.
10 foot wide boat.
This is the water, and this is the bridge. If your foot is 10 foot wide, can it go through the bridge? No, it can't, because this is 10 foot right here.
I've never seen a bridge that hard.
How wide is the bridge?
That is about 9.
Oh, you guys picture, like, get away from Tampa, Florida, and picture, like, an older city, like a Venice, Italy, where they do those, like, you know, those fancy boats, and they row through, like, that architecture. We're talking about, like, an arch was one of the first types of architecture. It's a very strong, when you stack bricks in an arch, they kind of all put pressure on one another, and they last a really long time. So arches are pretty common. I should ask you guys to find an arch somewhere. There's probably one in your house.
Promise.
Like in the newer built homes, they have arches. So if you find me a picture of an arch somewhere in our community, I'll give you 2 points extra credit. Find an arch in a building, and I'll give you 2 points extra.
We have to take a picture. We have to take a picture of it.
Take a picture.
That's easy. Just find one here.
Right there.
No, in a building.
We're in a building. I got the arch.
A part of the architecture.
I got the arch. I'm part of the architecture. That's the picture. Right there.
Hold on. She said we can have our phones.
No, the bridge is only 9 foot wide.
I don't know. I don't have a arch anywhere. I take that back. My ceiling in my room.
What was it? 0.5.
Mine's boring too. Like half of the wall is painted and then half of the wall is not painted yet.
Is that 190?
It's kind of weird because it's like
0.1.
yeah.
Just do 4.5 divided by 0.5.
I can be like this.
That is not a big. That is not a big bridge. That's not a big bridge.
You don't really factor the decimals this year. Alright, alright guys, flip to the back. Okay, so here, what we want to do is I'm going to challenge you to find intercepts of quadratics without graphing. So we're going to picture the arch, and we're going to do the math to find those intercepts without using Desmos. Okay, so the Desmos are going to help you visualize what you're looking for, but here we're just going to do the math. So, for this example, x squared plus 10x plus 21. Step 1, just go ahead and identify A, B, C. And if you look at this model here, A is the coefficient of x squared, B is the middle number in front of x, and C is the constant. So here I can see that A equals 1. It's an invisible 1 in front. B equals 10, and C equals 21. So in order to break this into 2 sets of parentheses, we need 2 numbers that will multiply to C, multiply to 21 it looks like, and add to 10. So what types of numbers would multiply to be 21? 7 times 3 is 21. And is 7 plus 3 10?
Yeah.
So 7 and 3 satisfy both these criteria. So those are going to be our numbers. We're going to write these numbers in parentheses, x plus 7 and x plus 3. Those are the factors. And now, that equals 0. So last step, solve each factor. The zero product property. And I found the intercepts of this archway, or this parabola, to be -7 and -3 without using Desmos. Now you can go ahead and go to Desmos and type it in, and you'll see the intercepts are -7 and -3. But finding the numbers yourself is required. But you can use Desmos to check. You need to put your phone away, man.
Unless you get the goose.
You missed the whole example.
I'll teach you.
I just hope the group chat was worth it.
It was. It really was.
After seeing it once.
You should just ignore that one and go to the next one. Are you guys ready for the next one? You guys think you can set it up on your own?
Yeah.
Go, ready, go. Do the next one.
I don't know.
You have a band-aid? I'm not even bleeding. It's just.
It
hurts.
Alright, so identify A, B, and C. A is the number in front of x squared, it's 1. B is the middle number, it's 17. And C is the last number, it's 30. So now we need to find numbers that will multiply to 30 and add to 17. Are there any numbers that you can think of that will both multiply to 30 and add to 17? 15 and 2. So you take those numbers. Did you follow that, Libby? You should get your butt out.
How do you know you're not talking with spots?
You can't hear it. This is audio.
Talking
So we're going to do x plus 15 equals 0 and x plus 2 equals 0. And the x-intercepts for this archway are -15 and -2. It's a U shape, not an archway. Wise. Did you take your earbud out or did you just ignore me? I'll start tomorrow with that for you.
What?
Take your earbuds out, put your phones away. Since nobody can listen. You guys literally need referrals to put technology away. It's embarrassing. It's embarrassing.
We don't need them.
You won't do it without them.